How does the tech that runs our world really work? We break it down to its fundamental truths. This is First Principles.
It's late, you've had a long day, and all you want to do is turn your brain off for a little while. You collapse onto the couch, pick up your phone, and open an app. Maybe it's Netflix, maybe it's YouTube, maybe it's TikTok. You don't have a specific plan. You're not looking for anything in particular. You're just browsing. And then it happens. The screen serves up a video. It's a clip of a comedian you've never heard of, telling a joke that feels like it was written just for you. You laugh out loud. Before the clip even ends, you swipe, and the next video appears. It's a short documentary about the making of a movie you loved as a kid. How did it know? You keep swiping. A chef demonstrates a ridiculously simple recipe for a dish you were just thinking about yesterday. A dog does something unbelievably silly. A short animation tells a beautiful, wordless story. An hour passes in what feels like 10 minutes. You've been guided down a rabbit hole so perfectly tailored to your tastes, your mood, your very soul, that it feels less like a product and more like a conversation with a friend who just gets you. It's a curator in your pocket, a personal DJ for your attention, and it is eerily, magically good at its job. We've all felt it. This strange, invisible intelligence on the other side of the screen. We've come to accept it as part of the fabric of modern life. We just assume that somewhere, in a server farm in Oregon or Virginia, there's a massive, complex artificial intelligence, a thinking machine that has watched us, learned us, and now understands us. It must be right. How else could it possibly work? But have you ever stopped to wonder how it actually works? If we could pause the video, freeze the frame, and peel back the layers of the app, what would we find? What are the fundamental rules, the first principles, that allow a piece of code to predict your desires before you're even aware of them yourself? Because the truth is, there is no magical intelligence in there. There is no understanding. The curator in your pocket doesn't know you at all. The story of how it really works is far simpler, far stranger, and infinitely more interesting than the magic we perceive. Today, we're opening the black box of the recommendation algorithm. The experience is so seamless now that it's hard to remember what it replaced. When you open Netflix today, you're not just seeing a list of movies. You're seeing a mosaic designed for you. The rows themselves, witty TV comedies, critically acclaimed sci-fi and fantasy, Because You Watched The Good Place, are all generated on the fly, just for your profile. Even the little thumbnail image for a show might be different for you than it is for your friend. If the system thinks you like romantic comedies, it might show you a picture of the two leads about to kiss. If it thinks you're a fan of a specific comedian who has a small role in that same movie, it might show you a thumbnail of their face instead. This is a level of personalization that feels bespoke, handcrafted. It's the digital equivalent of walking into a bookstore and finding that the owner has already pulled a dozen books from the shelves and stacked them on a table at the front, just for you. It's a service. It solves a problem. And the problem it solves is a very modern one: the paradox of choice. Think about the world before these systems became so sophisticated. Think about the late 1990s. The internet was just starting to feel infinite. Amazon wasn't the everything store yet. It was Earth's biggest bookstore. But even then, the problem was obvious. Their catalog had millions of titles. A physical bookstore might have a few thousand. How were you supposed to find something new? You could browse by author, by genre, or you could look at a curated list of bestsellers or editors' picks. But those lists were the same for everyone. They weren't for you. Or consider the video store. Remember Blockbuster? You'd walk in on a Friday night and be faced with the new releases wall. That was the main discovery engine. A few dozen movies, maybe 100, that the store's corporate office and the movie studios had decided you should see. Beyond that, you were wandering through aisles organized by broad genre: comedy, action, drama. The selection was limited by the physical space of the building, and the discovery was limited to what was new, what was popular, or what you happened to stumble upon by chance. Netflix started as a DVD by mail service, and they shattered the physical wall. Suddenly, their store had tens of thousands of movies. The problem of physical space was gone, but it was replaced by a new, more daunting problem: a crisis of discovery. When you can watch anything, how do you decide what to watch? An alphabetical list is useless. Genre categories are too broad. The sheer volume of choice becomes a kind of paralysis. You spend more time looking for a movie than actually watching one. This was the question that obsessed the early architects of the digital world. The problem wasn't a lack of content, it was a lack of curation. The world was building a library with infinite shelves, but no one had figured out how to build the perfect librarian. What they needed was a new way of thinking, a system that could navigate this ocean of choice and act as a personal guide for every single user. They needed to invent a curator that could live inside the machine. So, how do you start building a system like that? The first and most obvious idea is something we call content-based filtering. It's a very logical, straightforward approach. Let's imagine our curator is a very literal-minded librarian. You come to this librarian and say, "I just read Dune by Frank Herbert, and I absolutely loved it." The librarian takes the book, looks it over, and starts making notes. They create a little file card for the book. On it, they write down a list of attributes, or tags: genre, science fiction, themes, politics, ecology, prophecy, setting, desert planet, characters, young male protagonist, powerful emperor, giant sandworms. The librarian now has a data profile of the item you liked. Then they create a profile for you. They write your name at the top, and under it, they start listing the attributes of the things you enjoy. Your profile now says, likes science fiction, likes stories about politics, likes desert planets. The next time you come in, the librarian's job is simple. They look at your profile, then they scan the file cards of all the other books in the library, looking for matches. "Ah," they say, "you liked a sci-fi book about a desert planet? Here is another one. You enjoyed a story with a powerful emperor? This trilogy is full of them." This is content-based filtering in a nutshell. It recommends items to you because they are similar to items you have previously liked. It's all about the attributes of the content. Spotify might analyze a song and tag it with attributes like acoustic, fast tempo, major key, female vocalist. If you like that song, it will look for other songs that share those tags. A movie review site might tag movies with their director, actors, and genre. You watched a thriller directed by Christopher Nolan. Here are more thrillers. And here are more movies directed by Christopher Nolan. It's a perfectly sensible system. It's easy to understand, and it works, to a point. But if you think about it for a moment, you can start to see its limitations. The biggest problem with our literal librarian is that they can't create discoveries. They can only give you more of the same. You're trapped in a loop of what you already know. The system can recommend another epic sci-fi novel, but it would never think to recommend, say, a non-fiction book about the history of the spice trade, or a political thriller like House of Cards, even though the themes of power, dynasty, and control might be exactly what you loved about Dune. The librarian is trapped by the content. Their world is defined only by the tags on their file cards. They have no sense of poetry, no intuition for the strange and wonderful connections that leap across genres. The system is logical, but it has no capacity for surprise. To get to the kind of magical recommendations we experience today, we need a radically different approach. We need to fire the librarian and hire a mind reader. The real breakthrough, the conceptual leap that powers nearly every modern recommendation engine, is a beautiful and counterintuitive idea called collaborative filtering. And to understand it, we need to forget about the content entirely. Forget the tags, forget the genres, forget the actors and directors. None of it matters. Instead, let's go back to our bookstore. But this time, it's not a normal bookstore. It's a magical one. In this store, the books pay attention. When a person comes in and buys a book, every other book on every other shelf takes notice. Let's say you walk in and buy a copy of Dune. A little invisible mark is made. Later that day, another customer comes in. They also buy Dune. But they also buy a copy of a dense philosophy book called Gödel, Escher, Bach. The magical bookstore notices this pairing. It doesn't know what the books are about. One could be sci-fi, the other could be a cookbook. It doesn't care. It just knows that a single person bought both. The next day, a third customer buys Dune, and they also buy Gödel, Escher, Bach. The bookstore takes note again. A pattern is emerging. Over the course of a year, hundreds of people buy Dune, and the bookstore notices that a surprising number of them, far more than you'd expect by random chance, also buy Gödel, Escher, Bach. Now you walk into the store. You've never read Dune before. You pick it up and walk to the counter. As the cashier is ringing you up, the magical bookstore whispers in their ear. The cashier looks up and says, "You know, I have a feeling you might also enjoy this," and points you towards Gödel, Escher, Bach. You might be confused. One is a space opera, the other is a famous exploration of mathematics, art, and consciousness. On the surface, they have nothing in common. But the bookstore is recommending it to you, not because the content is similar, but because the people who liked the first book also tended to like the second. This is the profound, world-changing idea of collaborative filtering. It makes recommendations based on the behavior of a crowd of like-minded people. It's filtering information for you, based on the collaboration of thousands or millions of other users' tastes. The system doesn't need to understand why two items are connected. It only needs to know that they are connected in the purchasing or viewing habits of a group of people. This is where the first major misconception about these systems lives. We tend to think the algorithm understands us. We think it knows we like complex, philosophical science fiction, but it doesn't. The collaborative filtering algorithm knows absolutely nothing about science fiction. It doesn't know what a movie is. It doesn't know what a book is. It doesn't even know what a user is. The way to really picture this is to imagine a giant spreadsheet, a matrix. The rows of the spreadsheet are all the users of the service. Let's say there are 1 million users, so there are 1 million rows. The columns are all the items in the catalog. Let's say it's Netflix, so the columns are all the movies and TV shows. Maybe there are 50,000 of them, so you have a grid with 1 million rows and 50,000 columns. That's 50 billion little empty boxes. When you watch a movie and give it a thumbs up, the system finds your row, finds the movie's column, and puts A1 in that box. If you give it a thumbs down, it puts A1. If you haven't watched it, the box stays empty. The entire history of every user's taste is contained in this enormous, mostly empty grid. Now, the algorithm's job is purely mathematical. It has 2 simple tasks. First, when you log in, it looks at your row, the pattern of ones and ones that represents your taste. Then, it scans all 1 million other rows in the spreadsheet, looking for people whose rows look the most similar to yours. It's just a pattern-matching game. It's looking for your taste twins or your nearest neighbors in the data. It's looking for people who have put ones and ones in the same boxes that you have. Once it finds a group of, say, 1,000 users who are your closest matches, it moves to the second step. It looks at all the movies they liked that you haven't seen yet. It looks for the empty boxes in your row where they put a 1. If a huge percentage of your taste twins have given a 1 to a movie you've never seen, the algorithm makes a prediction. It assumes you're going to like it too, and it puts that movie on your homepage. That's it. That's the core of the trick. It's not an AI critic watching movies and figuring out what you'll enjoy. It's a statistical machine treating your identity as nothing more than a row of data and finding other rows that match. The recommendation doesn't come from a deep understanding of art or storytelling. It comes from the ghost of a crowd, the aggregated behavior of thousands of strangers who just happen to share a similar pattern of likes and dislikes. The magic isn't intelligence, it's just very, very big math. This approach is incredibly powerful because it can uncover hidden connections that a human, or even a content-based system, would never find. It can discover that people who love a certain historical documentary also tend to love a specific stand-up comedy special. Why? Who knows? Maybe both appeal to people with a dry sense of humor. Maybe it's a complete coincidence. The system doesn't know, and it doesn't care. It just sees the pattern in the data and acts on it. It surfaces discoveries from the collective, unconscious behavior of the masses. It also solves the new item problem. When a brand new movie is added to the service, a content-based system doesn't know what to do with it until its tags are analyzed. But a collaborative filtering system just has to wait for the first few adventurous users to watch it and rate it. As soon as they do, the system can see which taste clusters they belong to, and it can start recommending the new movie to other people in those same clusters. The information spreads through the network organically, based entirely on user behavior. Of course, it's not quite that simple in practice. The two methods, our librarian and our magical bookstore, are often used together. A system might use content-based filtering to solve the cold start problem. What do you recommend to a brand new user who has no viewing history? Well, you can ask them to pick a few genres or movies they like, and then use the attributes of those movies to make some initial suggestions. Once they've rated a few things, the more powerful collaborative filtering system can take over. This combination is called a hybrid system, and it's what most services use today. But even that isn't the full picture, because the true secret, the ingredient that took these systems from pretty good to scarily accurate, isn't about the type of algorithm. It's about the type of data we feed it. We've been talking about likes and dislikes, thumbs up and thumbs down, 5-star ratings. This is what we call explicit data. It's you, the user, explicitly telling the system what you think. For a long time, this was the primary fuel for recommendation engines. Netflix famously ran a $1 million contest, the Netflix Prize, from 2006 to 2009, challenging teams from around the world to build an algorithm that could beat its own system at predicting user ratings. It was a landmark event in the history of data science, and the winning teams built incredibly sophisticated collaborative filtering models based entirely on that one explicit signal, the star rating a user gave a movie. But in the years since, the industry has realized that what you say you like is far less important than what you do. The real revolution came with the rise of implicit data. This is the unseen giant. It's the data you generate without even realizing it. The system is no longer just listening to what you tell it, it's watching your every move. When you open Netflix, the clock starts. You're scrolling through a row of movies. Did you pause for a half-second longer on the thumbnail for Stranger Things than you did on the one for The Crown? The system logs that. That's a tiny, tiny piece of data, a whisper of interest. You click on the trailer. That's a much stronger signal. You watch the entire trailer. Even better, you add the show to your watch list, a huge positive signal. You finally press play on an episode. Do you watch the whole thing in one sitting? Do you binge 3 episodes in a row? The system interprets this as a sign of deep engagement. Or do you watch for 10 minutes and then turn it off to go do something else? That's a powerful negative signal, perhaps even more powerful than an explicit thumbs down. Did you ever rewind a particular scene to watch it again? The algorithm sees that. Did you fast forward through the credits or did you let them play? It sees that too. Every single interaction, every click, every pause, every rewind, every search query is a piece of data. It's a vote. You are constantly, unconsciously telling the service what holds your attention. And this implicit data is far more valuable than your explicit ratings, because it's more honest and it's generated in much higher volume. You might rate 1 or 2 movies a week, but you generate thousands of these little implicit signals in a single evening of browsing. And this brings us to the final piece of the puzzle. The platform that has truly mastered the art and science of implicit data feedback loops. The one that, for many, feels the most magical and the most terrifyingly effective: TikTok. The genius of the TikTok algorithm isn't that it's using some secret advanced form of AI that no one else has. It's that its entire design is built to generate and process implicit data at a speed and scale that is simply breathtaking. Think about how you use it. The content is short, 15 seconds, 30 seconds, a minute. The interaction is binary and immediate. You either swipe away or you don't. A swipe is a vote. More specifically, the timing of your swipe is the crucial data point. If you swipe away from a video in less than 2 seconds, that's a powerful negative vote. Do not show me things like this ever again. If you watch a full 15-second video, that's a strong positive vote. I like this. If you watch a video and then you immediately hit the share button to send it to a friend, that's a massive positive vote. And if you do the ultimate, if you watch a 15-second video twice in a row, you have just sent a signal to the algorithm that is more valuable than 100 5-star ratings. You have told it, this is exactly the kind of thing I want to see. Find more, now. Each of these interactions is a training signal that feeds back into the algorithm in near real time. With every swipe, you are refining your own recommendation engine. In a 10-minute session on TikTok, you might give the algorithm more feedback than you'd give Netflix in a month. The feedback loop is incredibly tight and incredibly fast. It's why the For You page can feel like it's adapting to your mood from one minute to the next. Because it is. The system places you in a cluster with other users, much like the collaborative filtering we discussed. But these clusters are constantly shifting and reforming based on this fire hose of implicit data. It notices that you, and a few thousand other people, tend to linger on videos of people restoring old furniture. Boom. You're in the furniture restoration cluster. It starts showing you more of that, but it also notices that within that cluster, there's a subgroup that also responds strongly to videos about baking sourdough bread. It will test you. It will show you a sourdough video. If you watch it, you're now part of that subcluster too. If you swipe away immediately, it learns that your interest is more specific. It is a relentless, ruthlessly efficient engine for finding the signal in the noise of human attention. But here we arrive at the final, crucial part of our story. The part where we have to step back from the elegant math and the clever engineering and ask a more fundamental question. What is this engine actually being optimized for? What is its ultimate goal? The answer is simple: engagement. The first principle of a modern recommendation algorithm is not to make you happy. It is not to educate you. It is not to show you the best content, or the most truthful content, or the most beautiful content. The single, irreducible goal is to capture and hold your attention for as long as possible. Full stop. The entire multi-billion-dollar apparatus is designed to maximize one metric: time on platform. And this is where the unseen giant truly casts its shadow. Because the things that are most engaging are not always the things that are most beneficial. The algorithm, in its blind mathematical quest for engagement, discovers things about our own psychology. It learns that content that provokes a strong emotional reaction, especially anger and outrage, is incredibly engaging. People will share it, comment on it, and argue about it, all of which are powerful positive signals to the algorithm. So it shows more of it. It learns that comforting, affirming content that confirms our existing biases is highly engaging. It feels good to be told that you're right. So the system will happily serve you an endless stream of videos and articles that reinforce what you already believe. It's not trying to put you in a filter bubble. It has no political agenda. It's just that the mathematical path of least resistance to keeping you on the platform is to show you things it knows you'll agree with. The filter bubble isn't the goal. It's a side effect of optimizing for engagement. The magical bookstore, which once promised to show us surprising new worlds, realizes that it can keep us in the store longer if it just keeps showing us the aisle we're already in. In fact, it starts to hide the other aisles. Over time, the store seems to shrink, until the only books left on the shelves are the ones that reflect your own face back at you. This is the profound and often invisible power these systems wield. They are not neutral platforms. They are active curators of our reality. They are shaping what we see, what we think, what we believe, and how we interact with each other. The TikTok algorithm doesn't just recommend dance trends, it creates them. By identifying a video that is gaining a tiny bit of traction and showing it to millions of people it predicts will engage, it can manifest a global phenomenon overnight. It is an engine for manufacturing culture. And it does all of this without intention, without consciousness, and without malice. It's just an algorithm executing its core command: find patterns in human attention and give people more of whatever holds it. It is a mirror, reflecting our own collective desires and impulses back at us at a scale and speed that is unprecedented in human history. So where does that leave us? We started our journey with a magical curator, a friendly ghost in the machine that seemed to know us intimately. We opened the box and found it wasn't magic at all. It was a clever combination of two simple ideas: recommending things based on their attributes and recommending things based on the behavior of similar people. We discovered the real secret wasn't some deep, human-like intelligence, but the power of a simple, counterintuitive trick: ignoring the content itself and focusing only on the patterns of the crowd. We learned that the true fuel for this engine is our own implicit behavior, the endless stream of clicks and pauses and swipes that we offer up every day. And finally, we saw that this entire incredible system is built on a single first principle: keep the user engaged. All of the complexity, all of the machine learning, all of the artificial intelligence is in service of that one simple goal: understanding this doesn't ruin the magic. It pulls back the curtain on one of the most powerful forces shaping our modern world. It allows us to see the architecture of our own attention. These algorithms aren't going away. They are the gatekeepers to the infinite library of modern culture, but they are not inscrutable gods. They are tools, and by understanding the first principles of how they work, we move from being passive consumers of their choices to conscious participants in the conversation. We begin to understand that every swipe is a vote, every click is a signal, every moment of our attention is a piece of currency we are spending to shape the world on the other side of the screen. The curator in your pocket is not a mind reader. It is a reflection, and the most important question it forces us to ask is not what is this algorithm showing me, but what do my own patterns of attention reveal about what I truly want?
You've been listening to First Principles. Until next time, stay curious.